So absorption of carbohydrates. So carbohydrates are absorption begins in the oral cavity where salivary amylase is secreted by the salivary glands to turn the carbohydrates into polysaccharides. Now, once the polysaccharides reach the small intestine, this is where the pancreatic amylase breaks the polysaccharides into disaccharides. And then there it's absorbed by the villi, where there are disaccaridases on the brush border of the villi, which turn disaccharides into monosaccharides. So there's three of them. There is sucrase, maltase, and lactase. And okay, so on the apical side of a enterocyte, there's the enzymes, the disaccaridases. So, and on the basolateral side, there's a sodium-potassium pump that maintains the concentrations of sodium and potassium inside and outside the cell to create an electrochemical gradient that helps actively transport glucose and galactose inside the enterocyte. However, fructose is passively transported into the enterocyte by a different system. And yes, and also the hexose co-transporter protein on the apical side moves sodium down the electrical chemical gradient that's generated from the sodium potassium pump discussed earlier, and this allows the active transport of glucose and galactose into the enterocyte. So glucose and galactose enter enterocytes via a sodium-linked secondary active transport system. So maltose consists of two glucose monomers attached by an alpha-1,4 glycosidic linkage. Sucrose consists of glucose and fructose, and lactose consists of glucose and galactose. And so once these monosaccharides enter the enterocyte by secondary active transport in the case of glucose and galactose, and passive transport in the case of fructose, then they leave by passive transport, all three of them, out of the enterocytes, and then it'll eventually go into the bloodstream, the hepatic portal vein, and into the liver, where it is converted to glycogen.